Welcome to this video. Today we are diving into one of the most absolutely incredible hidden bioengineering marvels on the planet. Literally right beneath our feet, tucked away in the dirt and rocks, trapdoor and tube web spiders are building these masterful, highly sophisticated sensory networks. It's kind of mind-blowing. So let's look at exactly how they do it. Here's a massive biological question for you. How do you hunt a moving target when you have no ears? Imagine you're a predator, right? You absolutely need to catch fast, unpredictable prey to survive. But here's the catch. You are completely deaf to the world above. In the spider world, there are absolutely no ears to hear airborne sounds the way that we do. If a bug buzzes by or crunches on a leaf nearby, the spider doesn't hear that sound wave traveling through the air at all. So how do you hunt a moving target in the pitch dark of the underground? Sounds totally impossible, right? But, nature always finds a way. And the solution they've evolved is nothing short of spectacular. The secret weapon here is an incredible biological adaptation called the slit sensilla. These are extremely sensitive, highly specialized hairs located right on the spider's legs. Instead of catching sound waves out of the air, these hairs basically act like an ear pressed flat against the ground. They pick up acoustic vibrations, which are essentially just sound waves, as they pass through solid matter like stones, soil, and silk webs. So, okay. They can't hear a fly buzzing around in the air, but they can absolutely perfectly hear the microscopic footsteps of an insect walking across the ground. They are literally feeling the sounds of the world through their feet. To truly dominate this environment, these spiders become the ultimate architects of the underground. See, they don't just sit in the dirt and hope a bug happens to walk over their toes. They engineer these ingenious, highly specific structures to maximize the reach of those sensitive leg hairs. Let's look at two specific master builders. First up, we've got the trapdoor spiders from the Chitinicidae family. Their design is a vertical underground tunnel, but the real genius is the door itself. They camouflage the entrance by building a perfectly hinged lid, carefully weaving together soil, small stones, plant debris, and their own silk. It is literally a hidden bunker. Then, on the flip side, we have the tube web spiders from the Segesteriidae family. They take a horizontal approach, usually building tube-shaped nests wedged right into rock crevices or old stone structures. Now, instead of a door, they extend these straight, highly tensioned silk signal lines outward from the entrance, making absolutely sure these lines are physically touching the surrounding stones. So we got two very different architectural designs. But as you'll see, they share one highly effective, deadly purpose. These structures aren't just for hiding, though. It's all about decoding the deadly vibrations. Let's look at how this physical architecture actually turns into an active, dynamic hunting network. Picture this. The spider is waiting in a tense ambush deep inside its dark nest. It isn't just resting in there, it's actively listening. It places its legs directly on the silk lines connected to the nest and that trapdoor lid. Honestly, it's exactly like a sonar operator sitting there with headphones on. Suddenly, an unsuspecting insect takes a step on the stones or soil outside. Instantly, those mechanical vibrations, the acoustic waves, transmit perfectly through the structure and shoot right into the spider's nest. But here's the truly mind-blowing part. The spider doesn't just know something is out there. By reading the specific frequency of that incoming vibration, the spider actually calculates the exact distance and the exact size of the prey. It processes all that physical data in a split second to decide if this meal is even worth the effort. Which brings us to a crucial piece of the puzzle, the acoustic stone advantage. You might be wondering, why would they spend all that energy to build with heavy little stones instead of just using plain soft dirt? Why actively seek out hard rock crevices? Well, this brilliant evolutionary choice comes down to pure physics. When an insect walks on soft soil, the vibration speed is much slower, and the energy loss is incredibly high. The sound wave basically gets muffled and just dies out quickly. But look at what happens with stones and hard materials. The vibration speed is way faster and the energy loss is very low. By purposely incorporating stone fragments into their trapdoors or building directly onto solid rock walls, these spiders are ensuring that the vibration, waves, from passing prey hit them lightning fast and crystal clear with almost zero signal loss. They're literally acting as acoustic engineers, selecting materials with the absolute best conductivity. Now let's put it all together and witness nature's lightning-fast ambush. Here is the complete strike sequence, and it is intense. Step 1 is the agonizing wait. They sit in ambush, legs resting perfectly on those taut silk lines, completely tapped into their underground network. Step 2 is the detection. The specific frequency hits the slit sensilla, and the spider calculates the exact size and distance of whatever's out there. Step 3 is the explosion. The absolute second it senses the vibration is just right, it flips open that hinge lid or bursts out of the tube entrance with literal lightning speed. And finally, step 4, the capture. It pounces, grabs the prey, and drags it right back down into the dark stone nest, all within a matter of seconds. I mean, it happens so fast the insect never even knew what hit it. It's a phantom strike, coordinated entirely by sound waves traveling through solid rock. And that brings us to this incredibly powerful summary from the source material. The nest serves as a massive acoustic antenna. That is exactly what these creatures have built here. It's not just a hole in the dirt. It is a highly tuned, bioengineered satellite dish made of silken stone, designed specifically to listen to the footsteps of the world above. It kind of makes you wonder, doesn't it? The next time you're out for a walk, stepping on some paving stones or brushing past an old rock wall, what other hidden ancient engineering marvels might be vibrating right beneath your feet, quietly listening to your every step? Thank you so much for joining me for this explainer. I really hope you found this whole thing as fascinating as I do. Keep questioning, keep learning, and I'll catch you next time.